Hello everyone. This is the second part of my earlier demonstration on Factorial ANOVA. So in my last video, I discussed the outliers and the missing values. And in this video, I will discuss testing the assumptions for Factorial ANOVA. Now, these are the assumptions uh, surrounding our or involving our factorial ANOVA. So observations on the dependent variable in each group must be randomly sampled and must be independent of each other. And that is more kind of a design issue. And we're not dealing with any kind of repeated measure here. So we don't have any kind of dependency, and we are assuming that the data um, sample is independent. Especially the values of dependent variable, that is the our income values, are independent of each other. And the second assumption is observations on the dependent variable must be normally distributed in each group. So this is specific assumption. We are creating 10 different groups here. 5 groups we have in the degree and 2 groups we have in this job satisfaction. So in all we have 10 groups. We want to make sure that our income 3 variable is normally distributed across all these 10 different groups. And the third assumption is the observation on the dependent variable must have equal variances. I'm sorry for that. Variances across all 10 groups. Okay, so that's what to keep in mind. So let's go ahead and start doing that. That's our data. We've been working on this one. So last time we created our income 3. Now we want to go ahead and start testing our assumption, because we have taken care of the missing values and the outliers. Now the best way to create the distribution across 10 different groups is to use what we call data split file. So it just create different categories as we specify. This is much better than anything else I've seen in SPSS. Let's do that. So I'm going to go with the split file here. I would say that compare groups. I already have this one, but I'm going to take it out. So let's say I want to compare the groups across degrees and job satisfaction here. Okay. And when I do that, SPSS is gonna divide my data set across 10 different groups, because we have 5 in degrees and 2 in job satisfaction, and perform the analysis across those 10 groups here. So let's say okay here. So it's gonna say okay, split file. We are doing it by this was my earlier command. So right now we executed these 2 commands. So the file is split. I know that. Let's go ahead and do our normal distribution assumption check. So I'm going to do here analyze descriptive statistics here, explore. Now all I have to do is mention my new variable R income 3 here. Okay, I don't need to mention anything in the factor list, because we already split across different groups, and SPS is going to take care of that for me. So I'll go to the statistics. I want the descriptives here. I want this time, let's say I want the box plot. Let's do the histogram, and and I want the normality plots with test as well. Okay, so these are 3 things that's checked. Options, again, it will just do the complete case analysis. It's going to exclude the cases list-wise, which means if any case that have 1 value missing will be ignored. So we want that thing, because we don't have that many missing values in our data set. We only have like 5-6% of the values or the cases that have missing values. So we're going to continue that here, and I'm going to say okay here. So it's going to create this nice big table here. Let's go to the case processing summary here. That tells you the statistics across all 10 different groups. So we have less than high school. For every category in the degree we have 2 categories for the job satisfaction: very satisfied and not very satisfied. So we can instantly check how many cell values are there. We want to make sure that we have adequate sample size in each cell. The bare minimum should be 20. That's what is recommended to get enough effect size and the statistical power. But here we see that here we only have 15. So that's a cause for some concern there. But overall, we have a good sample size. Another thing you have to notice here is, the cell sample sizes are highly uneven. So we have as high as 196 and as low as 15. So there's a lot of disparity there is there. Uh, if the cell values are even or close to even, that's better for the analysis. But I've seen in many literature or research, they still go ahead and continue the analysis because overall our sample size is pretty good. So I'll just go ahead and continue with my analysis here, and it tells you how many missing values are there in each cell. So you have 3 missing values in this one. So say if you have imputed the values for our income, because we don't have any missing values for degree and job satisfaction. We saw that in our last video, but we do have some 37 missing values for our income. So if we have imputed with the median for all the missing values, probably we would have got here 3 more. So that would have increased the sample size for this sub. That's something for you to consider when you're doing the statistical analysis. I like this split view better, and I would insist that even for your missing values and outlier analysis, you should look at this plots here, because it sort of gives you a global view of the entire data set across all the different groups that you're creating. So if you go to the box plot here, you can just go to the box plot. It's going to create 10 different box plot here. Let's jump here. That's RS. So this is less than high school level, and the people very satisfied. That's the box plot for this one. It's not that not normal. It's like looks pretty decent, very symmetric here. So is the less than high school versus not very satisfied. So basically you can see that you see some outliers here, not majorly any variable that you see extreme outliers as such. So these are pretty good. We did a very decent job. There are some here, but there are very few. So we don't need to worry about that. So we can just ignore this outliers here. But this is a better way to judge the outliers and missing values. Outliers could be judged again using your box plot, or you can also look at, did I create the stem and leaf plot here? Maybe not. So if you have that, you can look at the stem and leaf plot as well. So we did not do that, but that's another way to look at the outliers. Now let's go ahead and see our test of normality. So if you go to that table here, it tells you the significant value. Now the null hypothesis here is that the distribution is normal, and alternate hypothesis is distribution is not normal. So when you reject the alternate hypothesis, like you're doing it here for junior college, not very satisfied, that means this data is normal. So we have KS test and we have Shapiro-Wilk test. They're both saying that particular distribution, junior college versus not very satisfied, it's a normal distribution. And we do have one normal distribution here, and this is here as well. So these are all 1, 2, 3 normal distributions. I can at least see, or maybe 4, 1 as well. Yeah. So you can, others are not normally distributed wherever the value is significant. We are rejecting the null hypothesis and accepting the alternate, which says that the distribution is not normal. So we have most of the distribution, if you see here, are not normal. But the good thing with the ANOVA or MANOVA kind of analysis is that they are fairly robust and does not depend heavily on the fulfillment of this assumption of normality. So far, as far as we have, as long as we have good, sample size in each cell, and we do have a decent sample size for each cell. We have already seen that here, right? Only one cell is of concern, but otherwise they're pretty good. So we're not going to worry about that normality here. We'll still go ahead and do the analysis here. But let's see here. Let's say this one here, junior college versus not very satisfied. So not very satisfied. Let's see the distribution. It says the normal. Does it look like normal? So I'll just go to the box plot here. So that was junior college, not very satisfied, right? This one. So yeah, it looks pretty symmetrical here, right? Very close to the normal distribution. We can also see that here in let's see histogram here. Junior college, not very satisfied. It's pretty decent. It's pretty symmetric, normal distribution here. You know, not exactly normal, but very close to the normal here. Let's see another one here in my test of normality here. Let's see less than high school and very satisfied, which is right here. Less than high school and very satisfied, right? This looks pretty much normal here. Then we can also see the QQ plot here. See, these dots should be as close to the line as possible, and looks not that bad here. But keep in mind that here we have only 15 data values. That's something you have to keep in mind. So box plot for this one is very nice. It's very symmetric, and that's an indication of normal distribution. So this is how you go ahead and test the normality here. So as the test again suggests that most of the distributions are not normal, we still gonna go ahead and perform the analysis. So again, this is the split file technique is very good because it creates all the different groups that we want in our data set, and we can check the missing values in each cell. We can check the box plot for each cell for outliers, and we can also check the normal distribution for each group or cell. And as you see here, most of them are not normal. So, but ANOVA is pretty robust to the deviation from the normal distribution. So we can just go ahead and do the analysis. So I'm gonna stop my video here. Thank you very much for listening.